That's what I'm going to do. So we are recording right now. And here we go. Here's our agenda for today. Obviously, the big thing on our mind is our exam for Thursday. So we're going to talk a lot about that, what's on it, what you should expect, what's it going to look like, when's it going to appear, and so on and so forth. Looking ahead to next week, I'm not really sure what I'm going to do on Tuesday. I mean, I have a plan. I'm revisiting that plan, more to follow. Of course, the big thing of Thursday of next week, that's not this week, but next week, is that we'll all be on spring break. So something to look forward to. You all have certainly earned it. Be a good chance to shake it all out. So, but let's talk about the 25-meter target, which is exam number 2. So first thing, I just had a reminder there to record. I have this big pink sign up so I don't forget to record, and we're recording, so that's happening. Second thing on the list is this fill in the blank Pearson thing. So here's the deal. We've gone through this 2 times. I don't know why the system keeps crashing. There's folks out there, one who has a theory that we're all flooding the system. I don't know. I don't know about that. Here's what I'd say. If it's open and I haven't checked it today and you have time, get in there and try to get as many reps as you can. I know Pearson is Pearson. I know it's frustrating. If we get in this situation again today where we can't complete it again, we're just going to cease work. Points, things like that. Obviously, I want you to get the reps in. But if we get to that situation, I do not want you to stress out about this, okay? I'll figure that out, what the points are. I'm not going to penalize anybody, the folks who have done it already and the folks who haven't, okay? After a certain point, we're going to quit fighting the system and we're going to fight the war on knowledge. And Pearson is there so we get reps. D3M skills are built on reps. You have to appreciate that. But we can go to other gyms other than Pearson. There's a lot of great gyms out there. We have solo drives. We have U drives. We have today's session. You can make up problems for each other. There's problems in the back of the book and so on and so forth. So at a certain point, if Pearson's not cooperating, we're just going to cease work on that. But we're going to drive on and prep for our exam. So I will make that call if it has to be made. Hope is not a plan. Hopefully it doesn't have to be made. But bottom line, I know you've got classes today. You've got other classes other than this. You know, just get it while you can. And we'll see how tonight goes. Let's talk about exam 2. So exam 2, we're looking at all the stuff from block 2, and we're going to talk more about this. But some of you might be going, oh, so much stuff. 3 forests. Think in terms of 3 forests, single value X, sampling, and confidence intervals. And we'll talk much more about that. You've got a lot of references out there. I don't know why Joan's kind of down there like that. You've got class overviews that we've done, both in person and on Zoom. You've got all the drives, U drive, solo drive, squad drive. Today you're going to have power drive. You've got the videos that I've done, and those are all on YouTube. And of course, you got Almighty Pearson or some other name of Pearson. So let's talk about exam. 4 to 6 questions, pretty much like last exam. Okay. So when I say 6 questions, I don't want you to kind of, whoa, 6 questions. You know, I can take the same pizza. It's the same size of a pizza. So if I cut a pizza into 16 slices, it's still a large pizza. It doesn't make it any bigger. And so the analogy here is I might have 6 questions, but some of them are the same question, just with multiple kind of parts. So it's the same volume, the same format generally as last exam. When I say generally, the difference is it's going to be in a packet, and I'm going to show you that packet in a minute. Before I do that, I just want to talk about a few things with the exam. So, in terms of method, remember that this is an individual, open book, open note exam. The big thing here is just be mindful of the time. The exam's going to appear at 12:20 on the Canvas assignments section. This is on Thursday, this coming. So it's just going to appear, boom, and it's going to close, meaning you can't upload beyond 2:20. Okay. So you could be there right at 12:20 to download it. And in theory, you could take the entire 2 hours. That's all up to you. Or you could download it at 1 and upload it at 1:30. That's all up to you. Okay. But I want people to get very organized, very streamlined. When you go into combat, you're not like, oh, I'll figure out where my shield and sword is when I need it. No, you've got all that strapped on. You've got that size to you. You know exactly how to use that stuff. And the analogy applies here too with formula sheets, your notes. I wouldn't concentrate on having a volume of notes. I would have very minimal notes, not to restrict yourself, but so that you know when and where to use them. More on that later. Please do your own work. So, uh, if you've got a template built, I would just rather you build your template, you build your models during the exam if you choose to do it that way. And you will be able to do things, quote, by hand if that's what you want to do. Okay. But just please, don't cut and paste stuff into the exam. And don't like, hey, if you do the exam, I'll pay you $50 and send me yours so I can upload it. I mean, just, you know, those are bad things. And I think with this crew, we shouldn't have a problem with that. Here's how you get hold of me during the exam. I will be right here, okay, with Slash or Batman or somebody behind me, standing by for you. So you can zoom in. I'll be in a Zoom room. I will give you those instructions ahead of time. If you want to drop into my Zoom room during your exam to ask me a question, I've added to this since the other day. I've got my phone number on here. You can call me. Some of you might be like, hey, I don't want to mess with Zoom while I'm in combat. Can I call you? Yes, you can. I will be standing by waiting for your call. Please don't text me, though. I kind of think that defeats the purpose, and I just see stuff getting lost during text. So if you got a question, come up on the net one of two ways. And if you don't, that's cool too. My policy on questions during exams applies that if you get confused or you're in doubt or whatever, when in doubt, ask me the question. The worst thing I can say is, hey, I can't help you on that. But it's been a while since I've said that. I can't honestly remember the last time I've told somebody I can't help you. Okay. If you get lost, whatever, give it a shot. I will be there. I know some of you had concerns about that. Let's talk about what the exam is going to look like. Okay. So here is an example of an exam problem. And I'm going to post this to your Canvas once we're done here today, along with the slides, the power drive, this video, and probably a picture of Batman. I'm just saying. So let's get oriented to what we're looking at. First of all, down here at the bottom, you will I'm sorry, I've got a private chat coming in. Okay. All right, down here at the bottom, you'll have a tab for each question. So it's important that you stay oriented on which question you're working on. The 0 tab will be an instructions tab. I will get that out today, or at least before Thursday, so you have a time to digest the instructions and you won't be trying to read this for the first time in your time window. Okay. So let's just suppose we're on this question. Let's get oriented to what we're looking at. First of all, each question up here on the upper left will be a narrative. Okay. Your standard narrative, like in a U drive or, whatever, where we talk about what's going on. Okay. And if there's a data set involved or givens involved in the problem, of course, if they're givens for this block, you're probably going to have to shake them out of this yellow box. Okay. Now the box won't always be yellow. If on the next problem, this box will be here, but it might be orange. And the point there is I'm trying to give you a visual cue of you're working on a different problem. Okay. But you'll have a box here that kind of tells you what's going on and tells you the context. Okay. And then down below in the green, you might have some special instructions. I haven't fully written your test yet. I'm still finishing it up. But if I want you to round a certain way, I'll tell you. Okay. You shouldn't have a whole lot of stuff down here. And then you'll have the questions. Okay. So over here on the left, you've got numbers of the questions. You've got the question, what is a number between 1 and 100? And you put, if it's a very discrete answer, like 99, you just put that in that box right there. Okay. Now, there are questions where I ask you to interpret your results or justify your answer. And in that case, I'll give you something like this. Do you believe in the concept of infinity? That won't be a question, by the way. In 3 to 4 sentences, please provide your answer in the gray box. So you would jump down here and type away to your heart's content until you feel like you've answered the question. This is Excel, and the beauty of Excel is things are generally unlimited. So if I didn't give you enough space, keep on going. Okay. You don't have to fill the box either. If I said 3 to 4, then 3 to 4. Okay. I also put a little horizontal line down here, and that's so that okay, there's no more questions on this question. Cool. So it's kind of like a little finish line. All right, let's go back up on the top and talk about the right side. Okay, so over here, you want to show your work. So let's talk about first if you're working in Excel. If you're working in Excel, then great. You can cut stuff and paste it over here. You can build whatever kind of model that you want to build. You can do calculations. You can do, show your work. Let's say you don't want to do that. You want to do your stuff manually. Well, it's like we talked about the other day. You have a number of options here. You can write on a piece of paper and then take a photo of that and upload that along with this packet here. Okay, a couple things. I still want your answers here unless you're trying to draw something. And on this test, I'm actually trying to minimize the amount of drawing you have to do. Okay, because of the difficulty there. So anyway, if you are, hey, I want to do all my calculations, I want to write this stuff out by hand, but that's the way I've been doing it, and I want to stick with that, then cool. I want you to stick with that too. Take a photo of your stuff. You could paste it to here if you want to be snazzy, but I'm not evaluating on your ability to be snazzy. I'm just evaluating your ability to get the job done. So if you don't want to paste it in here, don't do that. Attach it as a separate file. I just got to be able to read it. That's it. And I'm pretty good with that. Okay. So just think about where you're going to be taking the test on Thursday. If you're going to be taking the test in a closet and you're taking photos in a closet, might not be the best idea. Okay. But you get the idea. All right. So you don't have to paste your stuff here. You can send it as a different attachment. Just tell me what question it is. And even if you don't do that, eventually I will figure it out. Obviously, as you're working and you're going along, not to insult anybody's intelligence, you want to save your work. And before you send this, you want to make sure that the stuff is in here. Upload that to Canvas, call it a day, go eat a piece of cake or whatever. Okay. At this point, I think I've said a lot of things. What I want to do is stop talking for a minute and see what kind of questions you have about anything I've talked about or anything else up to this point.
I have 2 questions.
Yes.
My first question is, I know on the first test, we, like, waited before we left or before we, like, exit out of all of our work that, we confirmed with you that it submitted on Canvas and we got everything. Do you want us to do that too? Like, do you want us to wait to get a confirmation from you before we, like, full on delete everything? Or should we just submit it on Canvas and see, like, what do you still want that, a confirmation, or are we
Yeah.
good?
Yeah. I don't think so I don't want the confirmation right away. All
Okay.
right. So let's just not worry about that. Let's be concerned with you and you getting it uploaded. And then at some point, I will get through evaluating them. So later, once I send you, hey, some feedback, that's probably the point at which we need to get rid of stuff. And my main thing is, I mean, you're on the honor system. Bottom line is, I mean, I'm thinking about future warriors and things like that. And if you're like, hey, let me hook you up to a friend and you're giving them a test packet and things. But after a certain point, I really can't control that.
Okay, and then I have another question. So a lot of like your videos and stuff like that is all like how you do it by hand. Would you be able to just make one video about like one question about the single value X sampling and confidence intervals on an Excel sheet, like how it would look doing the equations and stuff on that?
Yes, I can. I th- I think that I have something like that. Um, but I don't know if it's packaged that way. And the one that I think I have like that is one that I did with Lexi and a couple other folks last Friday. And it's on. So here's the deal, Cynthia. I'll either make a new one or I'll kind of edit that one a little bit to do what you're asking for. So
Okay.
this, let me make sure that I know what you're asking for. You're asking for me to show how I would do it in Excel.
Yes.
Okay. Yeah, I
Because I know
can.
how to do it like by hand on a sheet of paper, but I think that would be more time consuming if I'm trying to like fit it into that time. I think it'd be a lot easier to do it on Excel, but I'm not sure how to do that on Excel or if I'm doing it correctly on Excel. And I would just need more guidance
Yeah.
there.
Yeah. Well, after this, I'll give you a video right off the bat that I think talks to it. If I will make the time, make a new one. Um, and this is an individual decision for everybody. So first things first, Excel for the most part doesn't have a magic formula, especially when you start talking about sampling and confidence intervals. Um, so I'll put this stuff out there, but you all have to decide for yourself what am I most comfortable with at this point. Because if you're trying to learn something, all of you are at different stages and there's no right or wrong. But if you're trying to learn something brand new, this may contribute to frustration. But, again, I'm always there for you. So if you're like, I think I got this, but I kind of want to tweak it. There's been some folks where I'm showing this and I think I'm helping and I'm doing the opposite and just making them mad. And that's the last thing I want to do for anybody. So I will get stuff out there so you can make that choice. Does that work?
Yeah, that works.
Okay. Super. Other questions, concerns,
Can you
things that
hear me?
doesn't make sense? Yes.
So like today, are we going over like what's going to be on the test or just one part, or like what should we really focus on like reviewing before the test?
So we're going to go over that, and Travis, do me this. So toward the end, if I haven't kind of wickered that down for you, I want you to come back up on the net and say, hey, I'm still not clear.
Okay.
Not that you're not clear right now, but I think that's what we're about. I think in my mind, that's what we're about to do.
Okay.
Okay. Makes sense.
Cool.
All right. Tim, where is that? Is that Disneyland?
Yeah, it is.
Ah, okay. All right. Other questions before we begin?
If we're showing our work by writing it out, and if we're like finished the exam, but we're kind of like pressed for time, like just the time to upload the photos to the spreadsheet and then turn all of it in, like wouldn't it be easier to just email the work to you, the photos? Like, can we just do that?
Yeah, I'd be okay with that. I'd be okay with that. Photos only.
Yeah,
Well,
the entire spreadsheet. Like turn the spreadsheet in on cameras, but just send you photos of our work like through email.
yeah, that's fine, Greg. If you're
I
pressed for
just think
time.
that'd be easier than having to upload them first and then turn it in.
Okay. I'm good with that. I mean, this isn't that's fine. And I don't say that like that's fine, like I'm pouting or something. Uh this isn't an exercise in making it pretty and fighting the upload stuff. So if that starts to become an issue, then, or if you're concerned about that ahead of time, like Greg asked a question, let me know. Okay.
All right.
All right. What else? All right. Not a one-time question. I'm going to go ahead and show my screen again, and we're going to get into some review and power drive. All right. That goes away. Bum-ba-da-dum. Okay, before we do this, let's talk about this. So I'm gonna talk for a little bit, and hopefully all it is a little bit. And I have some videos of me downstairs in the gym, the back cave I call it, that you might watch and kind of get motivated by, or you might just kind of blow off. Regardless, I like to make the analogy of the forest, the subforest, and the tree. And so the question is, what am I talking about? Well, and why? What is the purpose of all this? So when we talk about block 2 and the knowledge that we've gone over since the last exam, I want you to make this analogy of, I don't know if you guys have ever heard of these dudes and dudettes. They're like smoke jumpers. So out in California, there's often a lot of wildfires. I don't think we have anybody from California. That's not a really good helicopter. It doesn't have wings. But anyway, so what they do is when these forests catch on fire, they jump into these forests. So, but if you jump into the wrong forest, then you're in a lot of trouble. You can't, really help. You might jump into a forest that's not on fire. So you got to see which forest you're being asked to jump into. I want you to think in terms of 3 forests. One is single value X. Okay, so anytime you have a question dealing with just one value, even though that value might change, okay, but just one value, that's what that forest looks like. Another forest is a sampling forest. Okay, and so that's where we don't have a single value X. We have more than one in the sample. We have a sample, meaning N is not 1. N is 2, N is 5, N is 100, N is 1,000, whatever, you get the idea. And then finally, we have the confidence interval forest. Okay, now hopefully, this is review for you, and you're not hearing this for the first time. You've heard me say this before in a video, and if you're like, I got it, dude, you said this 10 million times, then that's might be a good thing. This is a review. So you got to figure out before you jump out of that aircraft, which forest am I jumping into? Because if you jump into this forest and the problem deals with this one, you're going to have a difficult time. Okay. Now, you got to look for keywords within these forests. If this is a single value, you want to ask yourself, am I dealing with a single value, X, where the N is essentially 1? Then I'm in this forest. If I have an N involved, I'm automatically in one of these two forests. And if the question is asking me for a confidence interval, then I'm over here. That's a dead giveaway. I mean, I cannot, it's very difficult for me to write a question, although I can, without the words confidence interval. Remember, confidence interval, another way for it is an estimate. Okay? So if you are having difficulty, and I call this framing a problem. You get a whole bunch of words and people go, oh, I'm lost in the sauce. I don't know what kind of problem I'm trying to solve. It's okay. You are not alone. This is a strategic skill that you can develop, and you should continue to develop. Okay, so if you are having problem figuring out what type of problem I am solving, then think about keywords. And again, if you're like, I still don't get it, come up on the net and maybe we can do something about that. Let's talk about subforests real quick. Okay, here with single value X, all we really have is that X. Okay, I mean, that's the thing. All right, here we might be dealing with X bar, or we might be dealing with the sample proportion P. Okay, so this is kind of a subforest. All right, because I don't want to go jump off chasing a proportion and using those formulas if I'm dealing with a sample mean. Okay, because they're different things. And then same thing down here, only the brothers of those. So with confidence intervals, I have the population mean that I'm trying to estimate. And I also could have the population proportion. They are different things. Okay. So once again, you first assess your kind of current status of mad skills and go, what is my ability to frame a problem? Any problem. I just grab it blindly, pull it out of the deck, and we're going to do some of that today. What is my ability to frame the problem? And then beyond that, can I identify these subforests here? And all that is okay, I'm in the sampling forest. I'm dealing with sample means. Boom. Okay. Or I'm in the confidence interval forest. I'm trying to do an estimate, a confidence interval for the population proportion. Boom. You want to develop the ability to take a problem out of the stack and start wickering down how you're going to prosecute this thing. Okay. And then the trees are the types of problems that fall out of this. Okay. Let's just talk about confidence intervals real quick. All right. When we're talking about down here with the population proportion, well, that's pretty simple. I'm going to ask you either a 90% confidence interval, a 95, or a 99. Okay. There's one formula for that. Bam. Do you have to memorize it? No, you don't. Here, it's with the estimating the population mean. Things get a little tricky, but it's not impossible. We have one last question that we have to ask. Do we know sigma, the population standard deviation? Yes or no? If we do, then we have an Z table that we use, and we still use these 3 intervals here. In fact, we can use the same Z values up here that we can down here. If we do not know sigma, then we got to go to the T table, and that's a different formula and a different distribution. Okay, so again, do I know this? Yes or no? Can I recognize this? Yes or no? Can I recognize this? Yes or no? If your answers are yes, yes, and yes, then you're like on the 10-yard line. If your answer is yeah, but no, okay, well then we need to get stronger here. Okay. Let's talk about sampling. We have two big types of questions. Either that we have these things and we need to find out a probability, or that we have the probability and we need to find these things, a value. Okay. From my experience, these problems here, I call them the reverse, are the most perplexing to people. Okay. And one stumped me last Friday. I'm not going to lie. Okay. It happens. I make mistakes too. I kind of like mistakes because they kind of give you motivation to work through them and get stronger. All right. So failure to me is fundamental. I don't blow it off when I make mistakes. Actually, I think helps everybody. So anyway, now up here with single value X, let's talk about those trees. Those trees really aren't much different. We have where we have a value and we're trying to determine a probability, or the reverse when we have a probability and we're trying to determine a value. And of course, with both of these, we also have interval types of questions, meaning that an interval question to me, most of the time, is one of these other problems in disguise. So we might have, what is the probability of X being between 45 and 60? Okay, well, that's really two single value X problems disguised as one. We figure out the probability of 45. We figure out the probability of 60. We subtract the probability of 60 minus the probability of 45. Okay, so an interval problem really could be that in disguise, or it could be what is the probability, or what would the values be for 65% of the possible values for X. Okay, so that is another one of these in disguise. And then we have symmetric intervals, which almost is a confidence interval in disguise. So I know this looks like a lot here. If this is confusing, then we'll back out of this right now. If you're hanging with this, but you want to get more comfortable, I mean, this is all important, I think, to assessing where you are right now. Okay, so we're going to jump into some of this decision-making process. So right now, whether you like to or not, and last time I asked you guys, no one had ever jumped out of a plane. So we're going to jump out of some planes today. All right. Not really. Okay. But, you know, we're going to kind of do as much as we can virtually. So here we go. Here's how this is going to roll with the power drive format. I've got a question up on my screen, and it comes from somewhere of those forests, subforests, and trees. All right. So I want you to look at the question. I'll give you like 15, 30 seconds maybe. Okay. And then I'm going to free fire, ask kind of whoever I feel like it to, all right, let's get us started. How would you do this? I'm going to write up on the screen. I'm going to write some of what you say and probably add on to that. And I just need to get my stuff clean. So let's start out with this. If the population mean is 100 and sigma is 5, 75% of the sample means will be less than what value? Sample size is 16. Okay, so everybody take a look at that for a few seconds. Maybe jot down on your handy dandy clipboard, whatever. Get your brain thinking about this one. All right. So Jennifer, what type of problem, what forest are we in? with this. I think your mic is muted.
Sorry, my dog was barking earlier. That's why I had it muted.
It's quite all right.
So I'm going to say that we are looking for a probability based off of proportion, the sample proportion, off of
Okay.
by looking at it.
Okay. So you think this is
A sampling problem.
okay. So sampling problem. Okay. So that would be the big force that we're in. Okay. And then Tim, what do you think we're doing here? Jennifer said she said a couple things. So what do you think we're trying to do?
Would this be a sampling proportion problem because we have the 75%?
Yeah, see, that's where this one is really tricky. Okay, that's what it looks like. So we see that. Okay, but that's really a probability.
So it's like you would have thought because it was a percent, but since like why exactly is it a probability or a proportion?
Yeah, so this is all good. The reason it's it's a sampling problem dealing with X bar. Okay. And in the sampling problem, it's one of these reverse ones where we have a probability and we want to get something, we want to know a value of X bar. Okay. Now, here's the giveaways that we got to look for. Remember, we got to shake that problem. Number one, we're starting out with that, okay, which is the population mean. If this was a P problem, then we would have something dealing with P pop. Okay. Everybody, hopefully you see that. Okay. So this is deceiving, but this is a probability. Let's look at this. So we have our handy dandy hack daddy. And what I'm doing is what my number one recommendation when we get this kind of problem, let's just draw it out. Let's just draw it out. Okay, so keywords, we have mean here. This means this one mean, and then we have mean down here for Tim and everybody else. Okay, so sample mean is another word for X bar. Okay, so this is a sampling problem. The subforest is X bar. And it's a reverse problem. This is a probability. We're trying to determine that X bar value. Now, let's talk about tree time. Okay, what problem are we trying to solve? Less than what value? 75% of the sample mean. So if this is the mean, okay, and all of this area under the curve to infinity this direction and infinity this direction is 100%. Hannah, what do you think? Where would this X bar value fall if I move my pen down here?
To the left of the sample mean.
To the left? This is where things get really tricky. It actually will be to the right. Okay, so here's what I'm doing. 75% of the sample means will be less than what value? So this is 50%. So somewhere out here is that additional 25%. And that X bar value would be right here. And let's look at this again. 75% of the sample means will be less than that value. Okay, does that make sense to everybody? That's why this is one of the harder problems to deal with and why drawing is so valuable. Now, Megan, before I even do anything, the z-score that corresponds to that x value, will that z-score be positive or negative?
It will be, I think it'll be negative.
Okay, anytime I go to the right of the mean, the z-score will be positive. Because remember, a z-score is how many standard deviations I am away from the mean. So when I go to a positive, when I go right of the mean, it's going to be positive because my z-score at the mean is 0. So when I go left of it, it's negative. Okay, so I'm going to clear up some space here. I'm just going to preserve my drawing. I know my value for my mystery value of x is going to be somewhere out here, x bar, excuse me. And this is 75%. So, Travis, what do you think I do now?
Set up an equation to find the 75%.
Okay, what would that equation be?
I'm not really sure where to start.
Okay. Justin, what do you think?
Did you call me?
Yep.
What were you asking?
Okay. So I'm trying to solve this problem. All right. I know that I have a probability. I have that, and I'm trying to determine what x bar is so that 75% of the possibilities for x bar are less than that value. So what do I do next? What do I do with this right here?
I'm not sure, to be honest.
Okay. First things first, I'm going to turn that into a decimal. Okay. Second thing I'm going to do is either go to my Z table, and because it's a positive, I know I should be on this side. Remember my drawing? It looks a lot like this. Okay. See that Z looks a lot like where, well, my drawing board disappeared. All right. But the point is, I'm going to go down here and I'm going to look for 0.7500. Now, 0.7500 doesn't fall evenly on the table. But don't worry about that on the exam. I'm going to make it so it does. All right, here's what I'm talking about. I'm going to shrink down like Mike TV. I'm going to go in the middle of all these probabilities. I'm looking for 0.7500. And I don't have it cleanly. It's somewhere between these two. On the exam, I'm not going to give you something like that. I'm going to give you something that falls cleanly on it. All right, let's just say it was 0.7517. That corresponds to a z-score of 0.68. Okay, so I'm going to take that z-score and I'm going to get out of here. Okay, and get back up here. Remember this and this, and I'm trying to figure out what this is. Okay, but I have this z of 0.68. Now I'm going to use this formula. X bar equals Z times sigma over the square root of n plus the population mean. I have this, that's 100. I have this, that's 5. Sample size 16, so that would go down here. And I have this, goes right there. Okay. So just to put the ball in the end zone, X bar would be equal to 0.68 5 over square root of 16, which is 4, plus 100. Now, I want everybody to look at this, please. And let's look at what this means. So remember, my population mean is 100. So, Kendall, is my answer, don't worry about giving me an exact number. Is my answer for X bar going to be greater than 100?
Yeah.
Yeah, because it's 100 and this is a positive number. And I'm not asking you to stop there on the exam. I'm just saying conceptually that matches what we thought. Everything makes sense. Okay. And 75%, it's got to be to the right of the mean. So this is how you solve this problem. Okay. Now, before I forget, that whole shrinking down and going into the Z table. Let's say you're like, ugh, that's just such a pain. I agree. There's another way you can do that. You can take this, but remember, again, the key thing is if you thought this was some kind of proportion, and that's fine. That's a common mistake. Remember, this right here is population mean. Okay, so when we have this, we usually have this running around somewhere and not P. So we take this, turn this into 0.75. If you don't want to shrink down in the table, you could do this in Excel. And that will give you a Z-score. If you do this right in Excel right now, it'll return 0.68. But you need to know what that 0.68 is. Okay? And I don't say that, again, passive aggressively. I'm like, oh, you know, to each his own. I don't pick up a machine gun unless I know what it's going to do. I don't jump inside of a tank unless I know what it's going to do and if that's what I want it to do. Okay. So when I get this out of Excel, I need to understand that that's a Z-score, and I still need the rest of the formula to get the answer to this problem. Okay. To each his own. If that Z-score thing, and the beautiful thing about this is that I don't have to have an even number. So I can enter this. I take it back. You won't get 0.68 because I cheated. You'll get something other than 0.68, but it won't be too far away from it. Won't be too far away from it. Okay. All right. We're going to move on because, it's okay that we took time to do this because I think it's very important. And again, I have other videos showing how to do this. You'll have this video today. So let's move on a little bit. Okay. All right. Questions up on the screen. Cynthia, what kind of force am I looking at here?
would that be, this might be a wrong question, but would that be proportion of sampling? Like,
You think I made too much?
Let's see.
Single value.
Who said single value?
I did.
Kendall?
Mhm.
Why do you say that?
Because it's just asking for a single value x. It's probability of x will be less than what value, and that's implying just one value.
Okay, so what Kendall said is correct. Again, the indicators are there even more so this time. There's a 75% probability. So we have a probability. X, there's no X bar involved, will be less than, we'll come back to that less than, but what value? Okay, and then again, another tip off here is we have a mean. So while that looks like a proportion, it's not, it's a probability. Okay, so again, if we draw our picture, and hint, hint, this problem doesn't look very much different from the problem we just did. If we draw our picture here, and here's our mean of 100, Jared, where do we think that X is going to fall?
To the left or to the right. Sorry.
Okay. Jared is correct. It'll be somewhere out here. Okay. And the reason for that is because this is 75% and it's a less than question. Okay. All right. This would be the 25% and the greater than. Okay. So the approach is the same. We could either go in Excel and do norm S inverse, excuse me, 0.75, and that would give us a z-score, or we can shrink down, go in the z-table, and find whatever that is. The formula is different once we find that z-score. We're going to take that z-score. All we need is sigma. Notice since sample size of 1, it doesn't make a difference there. And then we have the mean on the end. Once again, if the mean is 100 for the population, we know that X, single value, is going to be greater than 100, which matches with our diagram. Okay, and again, it's a less than. All right, if it was more than, then we'd figure out this value, we'd actually do a 1 minus, but that's not the problem. We're focusing on this right here. Okay, let's go on to a new problem. Okay, take a look at this one. Let me get this stuff out of the way. Okay, Ricky is betting on a horse. Horse's name is Hot Mess. He knows that Hot Mess usually completes the race in 9.75 minutes with a standard deviation of 0.04 minutes. So, Jack, what is that 9.75?
9.75, that's, what do you mean?
So Jack's right. That is a mean. Okay, very good. All right. And what does that sound like? Does that sound like a sample mean or a population mean? You got a 50% chance of being right, Jack. Go for it.
Oh, can you repeat that?
So if this is a mean, 9.75, is
Yeah.
it a population mean or sample mean?
Sample.
So it's actually a population mean for the hot mess horse and his ability to run this race, or her ability. Okay. So assuming that hot mess's performance falls a normal distribution. All right. So we have some questions over here. What is the probability that hot mess will complete the race in less than 8 minutes? So Alyssa, how would you approach this problem right here?
X would be 8 minutes, or would that be the probability?
Well, you tell me.
It'd be X.
Yes. Okay. So then what do I do? If X is 8, whoops, sorry. So I have X, and what do I need to find out?
What the Z-score is.
Okay. Z-score will tell me.
The
So how do I do
probability.
that?
You solve for the Z-score using.
Greg, what do you think?
You do the formula, 8 minus 9.75, so x minus mu divided by 0.04 standard deviation.
Okay. And that's going to give me what Alyssa was talking about, was that Z-score.
Yeah.
Okay. And then I'm going to go down to my TV, so this is a Z-score, and I'm going to go to my Z table and find out what that Z-score goes to.
I got negative 43.75, which does not fall on there on the Z table.
You got a -4
I got negative 43.75
for the Z-score?
Yeah.
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 So that essentially means a probability of 0.0001.
Okay, yeah, because that doesn't fall on the table.
Yeah, so we fall off the table. Of course, we could also do this. So this is a single value X problem, like Alyssa pointed out. Okay, we have, and if we want to draw this, which is a good idea for any type of problem. Okay, hot mess's mean performance is there and has a standard deviation of 0.04. So really very, very little variation. So actually this curve would be really tight. Okay, Lexi, how do you think we do this one?
So where you put in 8 in your original equation, you would take 10 minus 9.75 and divide it by the standard deviation.
Very good. Okay, so Lexi's like same process and more than. Okay, so we're going to do that here, 0.04. And what is different though? There is one more difference. What is it? We're going to get a Z-score.
Well, once you get your probability, then you have to subtract that from 1 because it's more than.
Very good. Everybody see that? So here, once we get that probability, it is what it is. Because on this one, and I want, just give me blue. So I'm going to do this one. On that value, 8 is going to be down here. And when we say less than, we're talking about over here. And like Greg pointed out, with that type of standard deviation, this is way down here, and this is tiny. But over here on this other one, we're talking about this area. So that's why Lexi is indeed correct. We need to do a 1 minus for that. Okay, let's George, what do you think about this one here? Actually, this is all one question. So Ricky's bookie betting agent says, hey, I'll give you a 1 minute spread. You can have any 1 minute. So when we say a 1 minute spread, 8 to 9 minutes, you could have 10 to 11 minutes. You can have anywhere you want. To maximize his chances of winning, what should Ricky's bet? Which spread should he pick throughout here and why? What do you think?
So wouldn't we pick 2 points and subtract and see what the highest percentage would be?
Okay. Eric, George, you're on the right track. Eric, so running with what George said, what would you do with that? How would you approach this?
Subtract a minute from the mean and then add a minute from the mean so you can get the highest percentage on either
Okay.
side.
4.5.
Say it again.
So 8.75 and 10.75.
So it's 1 minute. That would actually be a 2 minute spread, but you essentially got it. So we would go 0.5 to the left.
Yeah.
And 0.5 to the right. Okay. So that would be between 9.25 to 10.25. That's a 1 minute spread. And that would be something like this. And the reason for that is look how tall this thing is. Okay, so that area under the curve, although it might not look much, but it's really tall. And that area is larger than any other area on here in comparison. So if we take this 1 minute thing and take like this area, that area is not as tall. Or this area, that's not as tall. So our highest probability with a 1 minute spread is right here. If it gave us a 2 minute spread, then like Eric said, we'd go half a minute this way and half a minute this way. We just keep building symmetrically on both sides out from the mean. Okay, but we wouldn't grab something down here and we wouldn't grab something over here. We would maximize our chances right here. Okay. All right, move on to another one. Okay, everybody take a look at this. I'll read it out loud while you're looking at it. John asks his Instagram followers how many have heard or had heard of the coronavirus before February. He has 450 people who respond and 200 say they had. So what is the proportion of people who had not heard of the coronavirus before February? Let's start with that. And along the way, we'll talk about what type of problem this is. I'll go ahead and read the last part. If John wants to determine a 95% confidence interval for the people who had not heard of the coronavirus before February, what would he do? So Brianna, why don't you start us off? Brianna, why don't you start us off? First of all, what is the proportion of people who had not heard of the coronavirus before February?
So you would take 450 minus 200, so 250. Have not heard of it.
Okay, so Brianna is correct. So again, this is and what type of problem is this, Brianna?
It's a confidence interval using P.
Very good. So confidence interval is our forced. Our sub-forced is P. Brianna did not get tricked. She said, okay, this says they had, but that's not what the question is asking for. The question is asking for who had not. So 450 minus 200 is 250 divided by 450, and whatever that is P. Okay? So Trent, I think I'm trying to remember who sang that song back in the day. Thomas probably knows. There was a song called Where Do We Go From Here? Anyway, I think it was the Alan Parsons Project. I digress. So Trent, where do we go from here to do this now that we know that?
So you want to do, you want to find the upper and lower
Okay.
of it.
Good.
Okay, so you're gonna do gonna be, is it gonna be X bar plus Z, or is that not the one?
Okay, so the short answer, and remember, everybody's a penguin here today. It's our safe place. So just because you don't know, I don't want anybody, I'm not trying to punk anybody out. But remember, this is a proportion. That's the whole purpose of this.
Oh wait, I got it.
Yeah, so keep going. Good.
So it'd be P equals P, and
Mm-hmm.
then plus or minus the Z score, and then the square root of P minus, or no, P times 1 minus P, and then over N.
Outstanding. Okay, so super. Great job. Who haven't we talked to today? Let me go to my other menu here. All these black screens, man. I think that you guys don't like me or something. Makes me cry inside. So Max.
Yes.
So what if we're doing this? Sorry, I got to catch back up. Okay, so if we're doing this for 95%, what is Z equal?
You have to go on to here, look at the table. For people who had not. 0.95. I'm looking at the table right now. So 1.65.
Yep. Now, Pearson, in its interesting way, has been using 1.645 on homework 2 Charlie. And it's being really stubborn about that. I'm not going to get caught up into this thing. If you use this on the exam, I'll figure it out. If you use 1.7, then I'll figure that out too. Okay. So if you use one of these, I really don't care. I know why they did that, but I'm not going to try to fix it all now and confuse you further. Okay.
Isn't 1.65 and 90%?
One.
Yeah.
Yeah, it is. And we're doing 95. So thanks, Kendall. I was sidetracked. All right. So it's actually 1.96.
Did you just find the Z-score from plugging in Excel, or did you do the math?
On this one, is that Travis?
Yeah.
So in your notes, and I'll just write it up here. For CIs, for 99, we know the Z's a little hack. Okay, I call this a Mike TV table. The Z-score is 2.58. For
Okay.
95 is 1.96. For a 90, I think, again, Pearson had been using 1.645. I'm good with that.
So the paper that you hand out with all the values on that is not where we get it from?
What paper is that?
The one with like the Z-score from like 0.0 down to 3.6, and then 0.00 to 0.09, then all the values in between.
I'm confused on what paper that is.
Z-score table paper.
What's that?
It's the Z-score table paper with all the Z-scores on it.
You're talking about this one?
Mm-hmm.
Right. Yeah. So like if you were to go to like 0.95 on the Z-score table, it gives you the
1.65.
Right. So that's like I think that's where it gets a little confusing, because if you go to 1, it tells you one thing, but then the Mike TV table tells you something else.
It should tell you the same.
I've always used the paper, and and I've had no problems with the homeworks.
Right. Okay, so they're all the same. I just want to be clear on that. It depends on what. So I don't know how you would get one on one or the other. If anything, looking at this, it leads argument to Pearson that wants to use 1.645 for a 95% interval, because it falls in between those two. But Max, I'm still confused when you say the paper.
No, that was it. This paper that's pulled up here is the one that I always use.
Okay. So
yeah, and it like came out to 95% for 1.645, but then for the value that you were showing that on the presentation, it said you wanted to use, that was the 90%, not 95%.
Okay. So
I'm wondering, yeah.
The reason it's different that you want to use the Mike TV table is because, so let me just get a different one and see if I can explain this quickly. So, okay, here's the deal. We got to know what we're doing. So if I'm doing a 95% interval, that means that 5% is not covered here.
Oh, okay.
Okay, and that means that 2.5% is not covered here or here. So that means, and again, if I'm confusing anybody, then quit listening. Just use the Mike TV table. And I'm not, that means this value here, Max, is 9.75. So when you go to the Mike TV, when you go to the Z-score table looking for this, for a 95% interval, that's why that's not going to work. You technically should be using this value to figure out what this is right here.
Okay.
All right. So
yeah.
This is kind of a higher level of this. And if folks are like, you're just confusing the crap out of me, then I hate to say, just trust me. I'm happy to talk through this with anyone, but that's why there's a difference. When you go and look for this, that equates to what Kendall was talking about, this. And not 1.65, because they're two different things.
Mm-hmm.
Now, let me, if I was doing this and I said, okay, I want to find 95% here. I'm given what value will cover values for X, 95% of the values. Yeah, then I would go to the Z-score table and look for 0.9500. And I would use a Z value of 1.65 or 1.645. Okay. But that's not what we're doing on a confidence interval. Okay. And I think we're about out of time. So I'm just going to stop here. Here's what I'm going to do. I have more questions that we didn't get to. So at a minimum, I'm going to post this quote sterile power drive up on your Canvas as soon as possible. I have some people that I've got to see for advising right after this. So I can't do a video with the rest of these problems. But I have another section today. I don't know if we'll get through all of it, because if I wasn't able to get through all of it with you, I don't know if I'll be able to get through all of it with them. Either way, I will give you a solution to these problems one way or another, even if it's just written. Okay? And I'll get that to you as soon as I can. I got a question from the field. Can we go into the T formula for confidence intervals? Okay, I'll just go into it very quickly about its confidence intervals, just super fast. And if you've got to go, I'm not offended if you need to drop off. I need to share my screen again. So let me do that. Okay, when do I use the T distribution? When do I do the Z distribution? I'm just going to use this as my little slate here. Okay, so again, I'm in the confidence interval forest. And the good news is that in terms of a subforest, I don't have to worry about P and the T distribution, so I'm not there. It's only when I'm dealing with trying to estimate a confidence interval for the mean. I'm in this subforest. My $500,000 question is, do I know sigma or not? If the answer is yes, I'm going to use Z, and I'm going to use the Mike TV table for values of Z, depending on 99, 95, and 90. Okay? And if I'm not, if I don't know the standard deviation for the population, I'm going to use T. There are two things that I got to know before I go into the T table. One is degrees of freedom, which is equal to n minus 1. The second thing I need to know is alpha half. This could get confusing. I like to just think about it. All right. When I'm doing a confidence interval like we just discussed, all right, if I'm doing a 90% confidence interval, I'm going to stop my confidence interval out here, and I'm going to stop my confidence interval out here. This distance, in terms of percentage of area under the curve, is going to be the same distance as the percentage of area under the curve here. And oh, by the way, the mathematical difference between this and this from the mean will be the same because it's symmetric. Okay, so when I do a 90% interval, that means the red, this plus this equals 10%. Okay, or 0.10. Half of that is 0.05. Okay, so alpha half would be 0.05. Here's where it potentially gets confusing. All right. So this value out here, remember, this is a 90% interval. Okay, so if you look at the top on the T table, I just like to look at for this value right here. That's why identifying that value is so important. It's not this one, it's this one. So for the exam, you will only need this T table because I am not going to give you a problem greater than 40. The other thing about this T table is it's nice and clean at the top. Okay, so once I know my degrees of freedom and my alpha half, I just go to where those values meet. So for example, let's suppose that my degrees of freedom is 12 and my alpha half is 0.05. I'm going to go down here, bzz, found my 12. I'm going to go over here, bzz, found my alpha half. And where do they meet? Right here. And so my t value would be 1.782. I always have to escape to get out of here. So 1.782. So T is 1.782. And then when I go back in my formula, a CI of 90%, I always lead with what I'm estimating for. And if I'm estimating for the population mean, mu, I'm going to lead with X bar because that's all I've got to estimate this. I'm going to go plus or minus. I'm going to put that T value in there. I'm going to use the sample standard deviation and divide that by the square root of n. Okay. How do I get the sample standard deviation? Well, one of two ways. It's either given to me, which usually in Pearson it is, or I have values for X and I take the standard deviation of those values, usually by going into Excel and using that and highlighting that array. Okay. So, I appreciate all you guys hanging out. I owe you a lot of things. I'm going to go ahead and